We're going to look now at recurrence relations. You won't have got to this point in your mathematical career without having heard of the Fibonacci sequence. It's found in things like flowers, in weather patterns, some say the sort of pattern of true beauty. And it looks like this. Where to form the next term in the sequence, we would need to add the previous two terms together. So 8 plus 13 gives me 21, 21 plus 13 would give me 34, 34 plus 21 would give me 55, and so on. Clearly, there's no common difference here because the differences are all different, and there's no common ratio either. So we need a different way that we can define this sequence, and to do that we use a recurrence notation. Now a recurrence notation is where you describe something that happens later by something that's happened already. So I start off by defining the first two terms in this case, so u1 is 1 and u2 is also 1. And then I set up my recurrence relationship to generate that next term in the sequence. To generate u of n plus 1, you're going to need to add together the previous term and the one that came before that one. So the next term in the sequence is the previous term and the one before that added together. This forms what's called a recurrence relation because the next term in the sequence is defined in terms of the ones previous. Let's look at how this applies to arithmetic and geometric sequences. So arithmetic sequences we knew were a, and then the next one was a plus d, and then the next one was a plus 2d, and so on, where the difference between each term is that you've added on another d. So we define the first term is a, and then we do this sort of generic to get to the next term. What you would need to do is you would need to take the previous term and then add on d, and this is our recurrence relation for this sequence. We can do the same thing with geometric sequences, so here we have a, ar, ar squared, and so on, where the first term in this sequence is a. Now our rule this time, to get to the next one in the sequence, what do you need to do? Well, you would need to take the previous term, un, and you would need to multiply that by r. And this gives us two examples of recurrence relations. Now all we're going to do is we're going to suggest a recurrence relation for the sequence 34, 18, 10, 6, so on. Now we might need to look at this for a little moment before we realise what's happening, but half of 34 is 17, add 1 will give me 18, half of 18 is 10, half of 18 is 9, add 1 is 10, half of 10 is 5, add 1 is 6. So my recurrence relation here, I start off by defining the first term. The first term is 34. Then I define my rule. To get to the next term in the sequence, u of n plus 1, you need to do half of the previous term, so divide that by 2, and then when you've done that, you need to add on 1. And that's how we define recurrence relations.